All right, great. So good morning, everyone. It's really exciting to be here. I was told by Lauren, the highest TDWI conference Orlando attendance in 10 years, so that's pretty awesome. She said no pressure for your talk at 8 a.m. in the morning, but everyone signed up to see you. Yeah, I know that's not the case, but I think some of the things I'm going to touch on are going to actually resonate with the same themes we're talking about the rest of this week. There's really a special moment that's happening in data science. Data science has been sexy for the last few years, and it's getting sexier. We have a real moment right now in artificial intelligence, which makes sense why so many people are actually drawn and are excited about what's going on at this time. So I'm going to be making the case today for AI-powered robotics, and also the case that data scientists are the most powerful people in this AI revolution because you are in control of the fuel, which is the data itself. There's a few stories that I'm going to tell today. The first is my story and how I became passionate about robotics. The second story is the story of big data in retail. And the third story is what my startup Cozy is doing within retail itself. And the fourth story is how AI and humans, I believe, are working together and are going to make each other better. So I was born in New York City and grew up in New Jersey. Don't hold it against me. I'm a really proud Jersey boy. When I was a wee teensy boy, I saw the classic 80s film, Short Circuit. And in Short Circuit, there's a robot named Johnny Five. And Johnny Five is created to wage war. But one night, Johnny Five is struck by lightning, and no longer does he want to wage war. Now Johnny Five wants to love. He wants to create. When I saw that movie, I knew I wanted to do that, but I had no idea what that was. But that night, in my room, using my mom's kitchen strainer, with my dad's sunglasses and his boombox on top of a swivel chair, all on top of each other, I built my first robot. Now, it didn't do much special. It played music, but what always inspired me most about my guy, Johnny Five, was his ability to be able to move through human spaces and interact with those spaces in the same way that a human does. More specifically, his ability to localize, navigate, and map out indoor spaces. So I was privileged years later to spend several years as a researcher working on these problems at UPenn's robotics lab called the GRASP Lab. And our team found our first commercial opportunity when a national retailer approached us and asked if they could use our tech to help them map out product store shelves more frequently. Now, retailers have a high demand for frequent inventory store surveys because more accurate shelving data enables them to make more money. So with our first commercial opportunity, we spun the tech out, we spun the team out, and we started Cozy. Brick-and-mortar retail environments are really messy. There's thousands and thousands of products that are tightly stacked against each other. It's actually the perfect place. And there's other stuff. There's communication dead zones, varying lighting. There's people that are walking around. It's the perfect human environment to test out an AI perception system that's transferable to other human environments. And that's what we want to do at Cozy. We built software that doesn't rely on any sensor modalities that humans don't have access to. No LiDAR, no beacons, no sonar, only vision and inertial sensing. Our goal is to enable robots to be able to understand human spaces in the same way that us humans understand those spaces in our minds. And we think unlocking a future where robots work alongside humans in environments that were built for humans, not robots, is going to be a very powerful future. So this is a video showing what we do at Cozy. So this is our software powering an off-the-shelf robot that is using only cameras to be able to navigate around the space. See that this is a view of the forward-facing camera generating a point cloud. That's the 3D position of all of the pixels in the space, and the robot generates that as it's moving through the environment. We go from movement and odometry to being able to stitch a 3D model of the world and being able to detect and recognize items along the shelf as we're driving through. This is completely autonomous. The robot is off the shelf. It's using our software. And we go from vision information that's captured on the machine to being able to present that in a way that's understandable to humans. So the visual interface there, and you can see the map of your floor plan, and you also have access to metadata around your product as well. So the robot travels around and it covers the entire store. And we see other applications for this technology on other platforms, right? We're not a robotics company per se. We work on drones, on smartphones as well. Our goal is to enable machines to be able to understand the world the way that humans do. So, like I mentioned, this is a really significant moment in history. It's apparent that something's going on. In 2015, this book came out, The Rise of the Robots. It claimed that all of us are going to be extinct or replaced. Robots are going to take all of our jobs, and humans and machines need to be pitted against each other. 3 years later, we have the lowest unemployment in the US in 20 years, by some measurements, as automation has been increasingly scaling and adopted by corporations. So what gives? Maybe we're very early in this journey and we really are all going to be replaced. Or maybe there's something else going on here and humans and robots can potentially work together. But either way, what's apparent is that we have to talk about artificial intelligence in a way that's much more realistic and practical, and also measured and with the right perspective as well. All right? My bet is that in 50 years from now, it's not going to be the political discourse or global instability that marks this time. This period in history is going to be known as the time when humans took their own genetic code into their hands and when AI was adopted by the world globally and scaled. Oftentimes, I'm at a conference like this, and there's someone at a podium like this, and they're saying things like, our organization is searching for the best artificial intelligence. Our organization is searching for the best artificial intelligence to solve our problems. And it's apparent as this person continues speaking that they have no idea what they're talking about, because there is no artificial intelligence that can solve all of your problems, right? The reality is that artificial intelligence is enhancing enterprise component software components and enabling them to have work more efficiently and to have new capabilities as well. So we need to talk about this stuff using the right definitions and using the right language. This is the definition of CRISPR. CRISPR is how humans are taking our gene code into our own hands. Geneticists are now able to code DNA with the set of characteristics that they wish. I'm not a geneticist, but I think this is an important point. I am an AI entrepreneur and a research scientist, and these are the definitions of artificial intelligence, robotics, and automation. Oftentimes, we use these terms and we blur them together. There are three distinct domains that are all related. The important point about this is that AI really drives the insight from data, and robots automate that action. And a robot might automate the action, like in the video that I just showed, or it might be in a digital environment as well, via something like a chatbot, which we'll talk about as well. So the title of my presentation is Data's Best Friend, Artificial Intelligence. There's really nothing revolutionary about that title, right? Obviously, AI is data's best friend because AI is a natural extension of big data. We're driving insights from information and potentially automating the analysis of that information as well, and the analysis of those insights. So since I'm at a data science conference, we have to talk about the 5 Bs of big data, and really specifically as well, the 5 Vs of big data within retail, right? So it's not always apparent to people that big box retailers grapple with big data. to me, it's quite obvious, and even regional retailers as well. There's 12,000 Walgreens that are located across the United States. There's between 1,000 and 3,000 Walmarts across the United States. There's between 1,000 and 2,000 Home Depots across the United States. At any given time, there's between 200 and 2,000 people on any one of those store floors. People are walking through those stores, and at an average rate of 10%, sometimes far lower, to 30%, they're going to make a purchase before they leave the store, usually using their credit card. And many times we're able to track people as they're moving through the store without ever having to have an associated ID as well, right? So we're talking about a lot of data, data of varying structure, and data that's driving quickly as well. This is a very simple structure of an enterprise software company, right? It's all about driving the prospective customer to an actual customer and then creating value over time through a relationship, usually by continuing to develop new products. The retail organizational structure is not all that different, but the retail store format is pretty fixed. There's not much innovation being done on the product side to enhance the customer experience dramatically. Over the last 5 to 10 years, though, almost every store has adopted a new e-commerce platform, right? And it's increasingly becoming that the e-commerce platform and the brick-and-mortar platform are linked. Tracking the customer profile and experience between those two environments is a really important thing for retail, often discussed in the omni-channel branch. Everything still surrounds driving the prospective customer to an actual customer and maintaining that relationship. Oftentimes, we take for granted our experience and our engagement when we're walking through a store. Folks in sales and promotion department of a retail store, at a corporate level, there's usually hundreds of people in this department, all dedicated to creating and designing the way that a store looks, creating and designing the way that you experience it. There's a reason, right? When you're walking down the cereal aisle and your child is tugging you on your back pocket, asking you to buy the fruit snacks. Well, the fruit snacks are located at the bottom shelf and next to the cereal. That's not by chance. If you are able to create and match the right recipe of products throughout the store, then you're going to be able to maximize your revenue as well. Operations within retail, we oftentimes take for granted. If I'm going to a store or your local Target, there's 250,000 people that walk through that on a weekend, your local Target store. Say, for instance, Tide is out of stock, right? Well, how does Target guarantee that they're going to be able to fill Tide back in stock when the next distribution center is 5 states away by tomorrow morning? That's a difficult problem, right? Now, Tide is a bad example because I know basically how many people are going to buy Tide on a regular basis. But what if Jennifer Lawrence posts a video to Instagram talking about or challenging kids to eat as many Welch's fruit snacks as possible? Well, you're probably going to have a pretty difficult time keeping up with the demand for fruit snacks. By the end of the week, you're going to be out of stock. How do we solve those problems? Are there better bets that we can make on how to influence our operations and also the way that we operate as an organization to meet customer needs? The demand on my delivery is going to directly influence how my distribution center operates. And increasingly, the distribution center in the brick-and-mortar environment, the line is being erased, right? There's a reason why Amazon purchased Whole Foods. Now, Amazon has an infrastructure in cities where millennials are flocking to, where they can enable delivery in under 1 hour locally, right? So this is a place where we play as a company, and I'll talk about that a little bit later. Exploring a little bit more the story of data within retail. There's an ensemble of IoT technologies that are enabling new customer experiences, right? So oftentimes when you're going through a Target store, you're using the Target app. There's going to be promotions that meet you when you purchase a product and you leave the register that are from your search history online, right? And there's all sorts of cool Big Brother stuff that's being done as well. You're being tracked with cameras as you're walking through the store. Many times an ID is associated with your person, but sometimes not. And your gestures are being tracked using that same computer vision tech. There's RFID technology that's tracking products, but that's also tracking you as you move through the space. The last time that I went to a Walmart, I was looking for a pair of goggles for swimming, and I asked where I could find it, and the customer associate took out their app and gave me and walked over using the directions on their app to where the product was. And I thought that was so cool. I was like, why don't I have that app? But I think it's even cooler that this data is being tracked by retailers. And not only what's in the stockroom and what's on the store floor, but also how many times that customer associate is actually being prompted to search for a particular item. It might be the case that that item is not even sold by the store. And now that insight can drive new decisions for that organization. And like I mentioned, right, we can track people, not cozy, we don't do this stuff, but technology enables tracking people using all sorts of methods, right? We can associate your ID to your place in the store using the right facial recognition technology, but more often we're actually able to track flocks of people as they're moving through a store floor plan and track your dwell time, right? How much time are you spending in front of a TV that you don't actually end up purchasing? So that's the story for big data in retail, or the beginning of the story of big data in retail. What for the story of AI in retail? So this is a map that's assembled by CB Insights. CB Insights is a database for venture capital firms. Cozy is actually represented on this map. We are towards the bottom there in-store robots. You can see our logo. We don't see ourselves under this category, but it's always interesting to see the way that the world sees you. One big takeaway from this map, right, which is focused on brick and mortar retail, but also covers e-commerce, is that this is a really big map, right? Brick and mortar retail has not that much budget for research and development, very tight profit margins. Yet there's this many companies in artificial intelligence that are serving this industry. So you can bet that whatever other industry you're in, this map is most likely a lot bigger. AI is here. It's here to stay. It has to be understood. So a few examples that I'm excited about of artificial intelligence in retail. Sales. So today we have applications like Salesforce that enable us to be able to collaboratively work together and track a person or a prospect as they move through our pipeline. With AI, now we have chatbots that are able to reach out to people, to leads, and many times actually make the sale for us, but often at least let us know when it's time to interact with that particular prospect. Customer recommendations. IBM Watson is pairing with folks like 1-800-Flowers. When you go online to order flowers, now you have an AI florist that's creating a boutique for you, or a floral arrangement for you, based off of your preferences, but also based off of your history, your ordering history, and the season. Manufacturing. This is one of the places that I'm most excited about. There's a few players in this space. One, AI is enabling us to be able to not have to walk through a plant, but instead to be able to have real-time information around the current status of an item in the assembly line. But I think even more interestingly, we have companies like Ganushu, through deep reinforcement learning, are enabling robots to actually speed up the speed in which they assemble items. Not because we gave them instructions on how to do so, but because they're learning how to do it over time. So this video will show you, and I'll post some of these online, how the Gugushu robot, it's actually the same robot, but powered by Gugushu software, is going to be outpacing it out and able to complete this task much faster through learning by itself. No human in the loop there. Logistics and delivery. So of course we're going to have Amazon drones that are delivering products to our window, but we're also going to have robots that drive up to our doorstep, deliver pizza to us, and keep our soda at the right temperature, right? This is an application that I'm most excited about, even though I don't think this is ever going to happen. Anyhow, it's actually being deployed in Europe right now. So this is showing these robots that are, this is a really sophisticated operation for delivering pizza, but that are driving this pizza off of huge trucks after being deployed to local neighborhoods and then driving right up to your door. And of course, we're able to pay online using PayPal, enhanced with artificial intelligence. Now we're able to actually track when a thief might be hijacking your account. So AI is taking all these enterprise software components to the next level. My thesis on retail specifically is that the applications that are going to scale are the ones where the ROI is the most apparent, right? So chatbots that are driving customer sales, I think that there's a real future there, right? It's obvious. Technology that can enable you to track where items are in your store and also decrease losses by 6 to 10%. I'm pretty excited about that software as well. So it makes sense that that's where Cozy plays. We've solved 3 practical applications for retail. The first is being able to actually create an architectural survey. We have a unit, either on a mobile phone or a robot, drive around the environment. It's able to create a 2D floor plan. That's what we call this 2D architectural layout. It's also able to show where shelving is located throughout the space. This enables a retailer to be able to maximize and optimize the use of the real estate. A realogram is a very retail-specific term. A lot of people are familiar with planogram. A planogram is the recipe for how products should be organized on a shelf. What we do is we check and see that those products are actually or organized that way. A realogram is how those products are actually organized throughout the store. So using computer vision, we track every product, and then we compare its current position with the way that it should be. And then out of stocks is pretty straightforward. If you're going to CVS and you're really paying for your Cool Ranch Doritos, and CVS doesn't have it, then you're going to go across the street to Walgreens. And CVS hates that because they're losing out on a sale, but Doritos hates it as well because you might just buy popcorn. One point that I'll make here is that we're solving 3 practical problems for retail, and this applies to other AI solutions in this space as well. But in order to be able to tackle these problems, it's taken a lot of work. So we take for granted how elegant we are as machines, as humans, how elegant and sophisticated our machine perception, our human perception systems are, right? In order for us to be able to tackle this, not only were we building on top of research, but it took 6 years of research specifically with our partners, and then 2 years of product development in order to be able to deploy this out in the field. So a little bit about our technology journey. All of the applications that Cozy tackles and the tech that we use falls under the branch of probabilistic learning and robotics. This specific domain and things that we solve often falls under SLAM in robotics, which is an acronym for simultaneous location and mapping. So a little bit about the definitions. Localization is basically finding your blue dot in the global map. Navigation is guiding you from point A to point B, or guiding the machine from point A to point B. And mapping is being able to create a very accurate map, 2D map of the space, but also a 3D map of the space. We call that the point cloud, accurate point cloud generation. And then fine-grained classification, which is being able to place a human, understandable, semantic label to each of these objects throughout the environment as well. And fine-grained classification is the one that we're most excited about. It's the one where really hasn't been tackled by anyone else. And I'll talk a little bit about what we're doing and what we describe as 3D visual search. So the first technique that we use for localization, and I'm going to talk about these components because hopefully as some engineers in the room, you find it exciting. It took a lot to develop each of these components, and I think it also provides some relevance and reference for how to tackle and how to approach some similar problems in different spaces. So visual odometry is basically the same technique that humans use when we're walking through a space. We're tracking 3D objects relative to us to determine our path and our pose as we're walking through an environment. We're then able to place our location within this room, within this hotel. Similarly, this is actually not a retail environment, but over a transit center. Using one camera and a sequence of images, this is one frame in the previous frame, we're actually tracking architectural features and determining their position relative to each other in each subsequent frame. By doing that, we're able to estimate the pose between frames and ultimately estimate the path of this smartphone. This is Philadelphia's 30th Street Station. Again, various lighting, cluttered. It's really a challenging environment to be able to map in. Unfortunately, the graph underneath is covered, but basically that gets at what I just mentioned. We're using two images that are input into our system, one frame in the previous frame, the current frame in the previous frame, and comparing the position between the two. And we do this basically in real time. This video is at 15 frames per second. So hopefully this map looks familiar. This is a 2D map of a retail store layout. Once we are able to determine the path that we're moving through the space, we're able to find our position in the actual environment. So you'll see in this space was mapped out by our robot beforehand, and now our robot is actually being guided around the entire environment that was pre-mapped. You see the blue dot in the bottom right, and then you see the stream of cameras from the two sideways facing camera sensors. So we use a deterministic planner, that's what we call it, for being able to navigate around this entire environment. The machine is given heuristics about the space, or an aisle looks like this, a wall looks like this, and once it's told that, it knows not to drive through walls, not to drive through aisles, but it has to cover the entire space. So using our navigation, it's able to do that. If we were to play this all the way through, we would see that little blue dot that's now on the far right drive around the entire store. So this is after the robot's driven around. You can see the path and sign there. Stitches together all of those images and creates a very accurate 3D model of the environment. So this is accurate 3D point cloud generation. And it's a fun model and fun to turn it around. There's a gap in the middle of this because the robot didn't explore that portion of the store. So a lot of times within computer vision, we hear about convolutional neural networks, and more, CNNs are enabling us just to throw data against a machine learning approach and to get a pretty accurate output. One of those approaches, or one place where that works really well, is facial recognition, right? Where you have thousands and thousands of examples of faces, sometimes millions, sometimes billions, and you throw all that data against a CNN, and you get a really accurate output. Problems in robotics are often, though, much more systematic, and so a much more systematic approach is required. There's not yet any technology or a tool that enables us to throw data and data against it and enable these capabilities. But one place where classic deep learning approaches have some relevance, and what we do, is the classification of objects on the shelf. So this is really similar to actually a facial recognition problem, where you might have many examples of faces, many examples of products, and you can throw it against a neural network. And by the way, a rising term within machine learning is explainability. Many times we don't actually know what the neural network does. We just know by making tweaks to this particular part of the architecture, it's going to enable this percentage in improved performance. So products are being detected and recognized. Maybe we could get away with throwing this at a neural network. But the reality is that at this point, being able to go from recognizing a bottle of water to determining if that bottle of water is a Poland Spring bottle or a Fiji bottle or a Dasani bottle is a much more difficult problem, right? So what we do is we use context about the environment, context about the product, like text, like the logo, like the boundary, in order to be able to enhance our recognition's performance. Seeing here basic neural network architecture. We simulate multiple perspectives given one template, which enables us to be able to perform better without having so much training data. And we see the output of some of our heat maps over some of the products in our sample space. At the bottom, we see the 3D point cloud, which is the 3D location of all the pixels. And I mentioned 3D visual search. That's what we're currently tackling, right? You give us a point cloud, and then we actually recognize what's the association or the label for every particular pixel in that point cloud. So the video that's getting ready to pop up is the robot's point cloud as it's moving through the environment. And then we're seeing projected in the 2D visual space bounding boxes around all of those items, and then the associated labels as well. This is not a problem that we have solved within retail over hundreds and hundreds of thousands of products, but it's one that we're actively working on and that we've made, I believe, more progress than anyone else. Also, we're the only ones talking about 3D visual search right now, which is where I think the world is moving. We're not a robotics company, we're a software company, as I mentioned. This is an example of our tech running over a fixed camera. People are interacting with shelves. We're going to see when Jamie moves that box of Apple Jacks and puts it in a different location. The system is actually going to recognize that and label the Apple Jacks that's in the wrong location in purple and the one that's been moved out of stock in red. So all the items are automatically recognized by the system, and then where they're moved between the planogram and the realogram is identified. We're then able to digitize all that information. So this, should resonate with things that we've seen from Amazon Go videos. The difference between where Amazon Go is today and where we want to take it in the future is that we're using, if Amazon Go is using a combination of techniques, right? RFID, touch sensors, in addition to cameras. We're using only vision-based technology. So the story for humans and AI. The revolution that's occurring is not so apparent. It's not as apparent as when ships were churning smoke down the lake or when planes started booming over our heads. This is being introduced to us through software that we use every day, right? So Siri was introduced to us 6 years ago, and she could talk with us, or at least she could try to, and it was sort of cute. 6 years from then, we now have things like Google Assistant that can interact with us and have seamless conversations with us and also on our behalf. It's much more subversive the way that artificial intelligence has crept up on us, and it's easy for us to actually miss the impact that it's going to have, that it's already having. This is a snapshot again from my favorite guy, CB Insight. This is called the AI 100. This is startups that have raised at least $50 million in capital and also have significant traction within their particular domain. Every sector of the US economy is represented here. So there is an emerging, there's an AI company that's gaining traction in every sector of the US economy. 3 of the companies that I think are really interesting from this list are Mighty AI and Figure 8. There's also a company called Crowdflower, or called Scotty Labs. And what these guys are doing is literally hiring thousands of people to help teach our machines how to understand the world. In some cases, people are being paid a higher salary to teach our machines than they're being paid to teach our children, which is really interesting. Here's a few examples of how this software is enabling humans to teach machines things, right? So this is from DataTurks. It's an interface showing how people are being shown how to interpret, or how people are showing the robot how to interpret this space, this table. The interface on the side is actually teaching robots how to react to human emotions when we're having conversations with them, which is really interesting. The missing gap right now is creating and curating tools, or actually creating tools that curate and organize data for artificial intelligence tool sets, right? Just like a toddler will look at the sky and be able to point, those things are white, those things are grouped together, they're round. She won't know that they're clouds unless her parents tell her that those things are clouds. Similarly, our robots have terabytes and terabytes of data that they've collected out in the field, but they have no idea how to make sense of it without the help of a person. And usually, the more complex the problem, the more people are needed. I think one of the next steps is, how do we actually automate the curation and the organization of this information? And that's in the hands of the people who manage all of this data, right? A few things that I believe. I believe that our core competency as humans is our imagination. We're not very good at the tedious and mundane. We have to have machines that are able to tackle the tedious and mundane for us. We could operate a lot more efficiently as a society, perhaps as even a species. For one example, bureaucracy, right? How much time do we spend filling out forms? How much time do we spend in useless meetings? Artificial intelligence perhaps has the opportunity for us to do away with those things, right? Perhaps it can enable us in the future to be able to automate the management of our city planning, the management of our government budgets. But I think even more intimately, we're going to have software that we're chatting with on a daily basis. Augmented reality might enable me to be able to see life through my friend's eyes. But what about your husband's AI? It's chatting with him on a daily basis. Say, for instance, you have a big blow-up argument. Well, your husband's AI knows his logic structure. It's going to know his emotional state. It's going to have readings from his heart rate, from other components of his health. Maybe will his AI be able to tell you why he has the particular perspective he does? Will it help you work out that argument? Or will his AI talk to your AI and help you be able to resolve the conflict? Some of this stuff is far-fetched. It's far out there. Maybe it will happen, maybe it won't. But it's in the hands of those who manage the data. Either way it breaks, it's going to be a very fun ride. Thank you, guys.